All right, ladies and gentlemen, welcome to the second video for your Systems of Equations Notes, Chapter 3, Section 1. This video is going to focus on the substitution method, which is an algebraic method for solving a system of equations. Essentially what we do is we solve one of the equations for one variable, and I honestly only use this method when one of the equations is already solved for one variable, but you will see one example here in the notes where it is not. We take that and we plug it into the other equation in the place of the variable for which it is solved. Solve, and we get the one, and we plug it back in and find the other. So here's what I mean by that. So let's look at the first example here. You'll notice the second equation says y is equal to negative 2x plus 7. Y is equal to negative 2x plus 7. So what we're going to do is we're going to take the y in the first equation, we're going to replace it with negative 2x plus 7. So that would give us 5x minus 3 times, and this is where that goes in there, okay, negative 2x plus 7 equals 23. That equation no longer has two variables. It only has one variable. As a result, we can now solve that equation for x. So we distribute the negative 3, which would give us 5x plus 6x minus 21 equals 23. We combine like terms. 5x plus 6x is 11x minus 21 equals 23. We add 21 to each side of the equation. Gives us 11x equals 44. And then we divide by 11. That gives us the x coordinate of our answer, which is x equals 4. Now what we do with that is we plug that back into y equals negative 2x plus 7. So since x is 4, we plug 4 in for x, which means y is negative 8 plus 7. That should be a plus, not an equals. I don't know what my brain is doing today. Or y is negative 1. Then we write our answer as a coordinate point, x, y. So the solution to this system would be 4, negative 1. Okay, our next example here is not yet solved for one variable. So our first step would be to realize that we can solve the second equation for x very, very easily by adding 4y to both sides of the equation. That would give us x equals 4y minus 5. Now the reason we want that is what we're going to do is we're going to take 4y minus 5 and substitute it into the first equation in the place of x. So that would give us 3 times 4y minus 5, or 3x, minus 2y equals 5. That equation only contains y and therefore can be easily solved for y. So we distribute the 3, 12y minus 15 minus 2y equals 5. We combine like terms. 12y minus 2y is 10y minus 15 equals 5. Add 15 to each side would give us 10y equals 20. And then divide by 10 gives us y equals 2. We take that y equals 2 and we plug it into the 4y minus 5. So x equals 4 times 2 minus 5, which would be 8 minus 5. So x is equal to 3. Meaning our answer is 3, 2. Okay, on the SAT, this will look a little bit different. It'll say if xy is the solution to the given system of equations, what is the value of x? So, or this is one possible way they could ask. Okay, so we only care about x. So what we're going to do is y is equal to these two different values, which means these two different values are equal to each other. We're going to substitute one equation into the other, meaning that 4x plus 5 has to equal negative 2x plus 5. We are going to then solve that equation. So I'm going to add 2x to each side and subtract 5 from each side. And I know what you're thinking. You're thinking, well, wait a minute. 5 minus 5, that's nothing. That's true. It is nothing. It's 0. So then when we divide both sides by 6, when we divide 0 by 6, that's not very interesting. We get x equals 0. Now we could still find y very easily if we wanted to by plugging in and saying 4 times 0 plus 5, but we really don't care what y is because the problem doesn't ask for y. The solution to the system is the 0.05, but this question says, what is the value of x? Remember that on the SAT it is very important that you answer the question that was asked. In this case, x is 0. The other thing they might do on the SAT is they might give you a system, and then instead of asking you for the coordinate point, they might ask you to evaluate another function. So for instance, if we look at example D, it says if WZ is the solution to the system of equations below, what is the value of W times Z? So we are going to substitute because the second equation is already solved for Z. By now we should be comfortable with the idea that I'm plugging that 3W in for Z to get me an equation that I can solve. So that would be 2W plus 6W equals 48. Combine like terms would be 8W equals 48. Divide by 8, and we get W equals 6. If W is equal to 6, then Z is 3 times W, so 3 times 6, so Z is 18. Now the final step is to take those values and multiply them together. W times Z would be 6 times 18. We would multiply those together. That's, 108, I think. I'm going to grab a calculator real quick and check my numbers there. Okay. 6 times 18 is 108. So the answer to this question is 108. WZ is equal to 108. Okay, that does it for our second video. The third and final video for this section will focus on the third and final algebraic method that we learned in this course, which is the elimination method. Thank you for your time and attention.